Okay, let's talk about arithmetic sequences and series. So an arithmetic sequence is a sequence in which each term after the first is obtained by adding a fixed number to the previous term. The fixed number is called the common difference. So like here, 5 to 9, there's a difference of 4 units there. 9 to 13, there's a difference of 4 units there. 13 to 17, same 4 units. That's an example of an arithmetic sequence. So I want to find the common difference here. Well, notice that on this slide, right, I could have taken any one of these in sequence, 17 minus 13, and come up with that common difference of 4. So I'm going to do exactly that here. I'm just going to take any two in line, 1 minus negative 5. I do the second one minus the first. 1 minus negative 5 is 1 plus 5, so 6 is my common difference. Notice that 1 to 7 is a difference of 6, 7 to 13 is a difference of 6, and so on. I want to write the first 5 terms of the arithmetic sequence, whose first term is 13. Okay, there's our first term, and the common difference is negative 3. So subtract 3 from 13, we get to 10. Subtract 3 again, subtract 3 again, subtract 3 again. There's our first 5 terms. Notice the next term in the sequence would be a negative 2. Let's write the first 5 terms of the arithmetic sequence, where A1 is a negative 40. That's our first term. And the difference is 5. So I'm adding 5 to the next term. Negative 40 plus 5 is negative 35. Then negative 30. If I add another 5, I get a negative 25. Add another 5, we get a negative 20, and there are our first 5 terms. Now, our nth term can be given by the formula a1 plus n minus 1d. Let's look at that here. Notice if I wanted my third term, I would say I had to subtract 5, or I had to add 5 once here, and then add it again here. So I had to add it 2 times. 2 times is 1 less than the third term. So 3 minus 1 would be 2 times that common difference added to the first term. Okay, so let's find A13 for the arithmetic sequence, negative 9. Now notice here, my first term is the negative 9, and the common difference is 5 minus negative 2, so 7. So using n equals 13 would go A13 equals A1 negative 9 plus n, okay, so my n is 13, so 13 minus 1 times that difference of 7. So negative 9 plus 12 times 7 is 84. So 75 is my 13th term. Now the general term a sub n, I find just by substituting into this formula. Negative 9 plus n minus 1 times the d value, which is 7. So I'd write negative 9 plus, distribute the 7, 7n minus 7. So I would have 7n minus 16, that nth term. Let's find A18 and AN for this arithmetic sequence. So again, here, my D is, well, these are in order. So I'm going to go negative 3 minus 6. I get a difference of negative 9. If my difference is negative 9, then the A1 term would be negative 9 before this. So what would I have to have subtracted 9 from to get to 6? It would be 15. So that tells me that A1 is 15. So I would go A18 is 15 plus 18 minus 1 times the negative 9. So that would give me 15 plus, okay, that's going to be 17 times negative 9, and that would be negative 153, I think. And then if I add 15 to that, that should take me to a negative 138. Now the a sub n term would be my 15 plus n minus 1 times the negative 9. So distributing the negative 9, I would have 15 minus 9n the sum of the first n terms of an arithmetic sequence is given by this formula, or equivalently this formula. I'm just substituting in the formula for an into this expression to derive what's here. So I want to evaluate S22, the 22nd sum. So I want the sum of the first 22 terms. So my n is 22 over 2. 2 times the first term is right here, 3, plus n is the 22, times the d, oh, we forgot to find the d. D is 10 minus 3, so 7. All right, let's work all that out. So 22 divided by 2 would be 11. 2 times 3 is 6, plus 21 times 7 is 147. So that would be 153 times 11, and 153 times 11 is 1680. The sum of the first 17 terms of an arithmetic sequence is 187. If we know that that 17th term is negative 13, let's find the first term and the d. So we're going to use our formula. S17 is 17 divided by 2. This time we're going to use the form of A1 plus AN, so A1 plus A17. So we know the sum equals 187. So that's equal to 17 divided by 2 times A1 minus 13. This is going to allow me to solve for A1, because what I'm going to do is I'm going to multiply 2 to the other side and divide by 17, and that gives me 22. And then add 13 to the other side, we find out A1 is 35. So that's our answer there. Now we need the D. So to find the D, we're going to use our formula for A17. A17 equals A1 plus n minus 1, so 17 minus 1 times the D. So A17 we were told was negative 13. We figured out A1 was 35, so that's 16D. So I'm going to subtract 35 to the other side, I get negative 48, and then divide by 16, I get D is a negative 3.